Hello, everyone. Good afternoon, dear authors and invited guests. Welcome to the technical session 4A. Myself, Richa, and this session would be moderated by me. On the behalf of the Global Knowledge Research Foundation and the GR Solistic LLP, it's my great pleasure to welcome you to the 9th World Conference on Smart Trends in System Security and Sustainability, WS4 2025, London, UK. The ninth edition of the conference is being organized in hybrid mode. The physical event was held yesterday in London, and the virtual event is being through Zoom today and tomorrow. I hope you will enjoy the knowledgeful and interactive session through the day. In this session, we have 6 presentations. Each presentation will be given 12 minutes for presentation and 3 minutes for question answer. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or any update, write it to me in a chat box. Just before we get started, I would like to introduce you to all chair of this session.
Hello.
Professor Eminel. He's a senior lecturer in the University of South Africa, specializing in higher education and educational technology and adult education. His expertise also span in information system and software engineering with a focus on integrating technology and innovation to enhance learning and professional development. Welcome to you, sir. And we have another session chair, Dr. Meenakshi Sumitarya. She is a senior director of AI research at Create AI India. She is an experienced research expert with a notable background in the field of artificial intelligence and deep learning, processing as diverse skill in a machine learning, big data analytics, algorithms, data structure, and C++. Her specializations are machine learning, deep learning, AI strategy, computer vision, algorithms, data structure, AI strategy, research and development, and stakeholder engagement. Welcome to you, ma'am. I would like to start with papers. Now we can call our first presenter, Saraswati Sarkar, sorry, to present her paper title on dynamic load balance monitoring using heterogeneous loads.
Hi everyone, I am Saraswati Sarkar. Is it audible?
Yes, ma'am, it is audible.
Is it audible? Okay. So can I share my screen?
Yes, please.
Can I start now?
Yes.
Okay. Hello everyone. I am Saraswati Sarkar. I am research scholar in computer science department. My supervisor name is Dr. Anirban Kundu from Netaji Subhash Engineering College, Kolkata, India. The title of my research topic is Dynamic Load Balance Monitoring using Heterogeneous Load Balancer. The agenda of this paper is aim, challenges, introduction, related work, proposed work, experimental result, scope, and summary. The aim of this paper is mainly develop one framework for loading the incoming request in the storage system by using heterogeneous load balancer. And in this framework, to introduce this framework, there are following two major factors are used to introduce this framework. Number one is least response time method load balancing and least connection method load balancing. The introduction is included with load balance monitoring, load balancer, and heterogeneous load balancer. Load balance monitoring mainly a process who balance the distributed data traffic in a multiple services or multiple server, and it will make the storage system more high performance and reliable. And a load balancer is mainly a device which ensure that the incoming requests are distributed properly in the total system, and it make the total system more scalable and available. And heterogeneous load balancer is mainly to process which distribute the workload across the different computing system, and it is depending upon the different capability of the process of work like bandwidth, capacity, and the processing power. Related work is included with two load balancing system, that is least response time method utilized for load balancing, that is represented in figure 1. Here there are two user, and from these two user there are 5 requests. It has been taken here, request 1 to request 5, and by using load balancer there are 3 service. Here mainly calculate the response time of each services, and according to the response time the requests are loaded in a particular service by using the load balancer in this load balancing method. And the second one is the list connection method utilized load balancer balancing. Here actually here also the 3 services are used, and here mainly calculated the 10 connections, and there here request 1 to request 5 is coming from the user, and by using load balancer depending upon the connections it has been loaded in a particular services. These are the related work. Now in proposed work, this is the proposed from in proposed framework mainly heterogeneous load balancer are used to direct the request in a multiple servers, and here first choose the minimum response time from each service. There are different type of service are there, and calculate the response time and minimum response time I have to choose here for the particular server. And the load balancer calculate the number of connections of the each server. In this way, depending upon the both criteria, the number of connections and the response time, the incoming request or data traffic are loaded by the heterogeneous load balancer in this system in a particular server. So this is actually the picture of proposed framework where user 1 to user n are considered here, and here is a heterogeneous load balancer has used to balance the request. N number of requests are coming in the system, request 1 to request n, and there are 3 services 1, 2, 3, and each service it has been shown here the response time and the number of connections, and depending upon these two response time and number of connections by using the following proposed algorithm, the requests are going to the particular service by the heterogeneous load balancer. Now, this is the algorithm 1. Algorithm 1, name of this algorithm 1 is monitoring and balancing. Here, incoming requests are input that is R1 to Rn, and balance R1 to Rn after this is the output. Here, two functions are used. Number 1 is dylb underscore monitor function and hlb function. dylb function is mainly monitor the incoming request according to different type of parameter, and HLB function that is called here, which is actually used to load the incoming request in the particular service for the better resource utilization. Now this is algorithm 2, that is dylb monitor functions definitions. Here inputs are incoming request R1 to Rn, and output is distribute the request. Now here load balancer calculate number of connections, and it has been number 1 number of connections it has been calculated, and number 2 is the response time has been calculated here for each server. So that is represented by RT, response time is represented by RT, and service 1 is RTS1. For service 2, response time is RTS2. In this way, RTSN are all the response time of each server. Now select the least response time from RTS1 to RTSN. Now here calculate the total time. Total time is calculated, that is denoted by service 1, that is S1T, that is calculated by number of connection multiplied with the response time for service 1. Then S2T means number of connections multiplied by service 2, number of connections now and response time of service 2. That means here it will be multiplied and calculate the total time for each service by the number of connection of particular service and the response time of particular service. That will be multiplied and get the total time of particular server. In this way, the load balancer calculate and monitor the connection of the response time connections and the response time of each request. And after this calculation, then it has been decided that in which service is which request is going to the which services by using this heterogeneous load balancer. Now this is the algorithm 3, that is the name of this algorithm is HLB. Here input has taken by total time, that is S1NT to SNT, and to distribute the total request after that is considered as an output here. Here we select the, I select the largest of the total time, that is S1T to SNT, and in this way move the request particular service from these all the services in a particular manner by using the heterogeneous load balance technique. Now, next one is the analytical discussions of the heterogeneous load balancer. In analytical discussions, we considered here the two requests here, and here actually I consider only the criteria, that is the length of each request. So here compare R1 with the R2, request 1 with the request 2, and here it will be balanced according to length, that is considered here R1 less than R2, and it will be balanced by the balancer, only one balancer. Now if there are 3 requests is coming, then R1, R2, R3, then R2 is added with the R3 and compared with R1 first, and balancing by the balancer. Now in next stage, R2 is compared with the R3. Then in this way, by using two balancer, three requests are balanced in a particular service. Now, if we consider four requests, then R1, R2 is added, R3, R4 is added. Both are, compared with each other, and by using one balancer, and balanced by using one balancer. Then again, R1, R2 is compared, R3, R4 is compared. Then it will be compared with each other, each request, and by using three balancer. It has been shown here that three balancer is used here to balance all the 4 requests. Now, in this way, if we are considering the n balancer, the n request R1 to Rn, that will be calculated in R1, R2, R3, R4 in that way. Then each and every step, it will be compared with each other, each request with other request, and after that, it will come that from R1 to Rn, if we want to balance, then it will be balanced by the B1 to Bn minus 1 balancer for loading the system. The requests are loading in this way in the system. Now, this is the congestion control structure of the framework. In congestion control structure, it has been represented here four input, that is the resource input, time input, delay processing input, and processing input. There are 4 inputs are here, and in this framework, it has been shown here that all input are going to the particular system or particular system or particular framework in proper way. And here the congestion controller control the
Dear presenter,
system.
sorry to interrupt. You have last 2 minutes, please.
Okay, I'm done. I'm almost done. There are congestion controller control the total system, and in this way the inputs are going in the following way, and it has been shown here that the traffic is not here, and it will be input are going in the following input are going without any congestion. Now in experimental result, there is calculated average response time, and here it has been shown in graphically that the proposed method response time is less in the existing method because and it will give the better result than the existing method that is graphically represented here. And the load balancer, it has been calculated here. I mean, load balancer is that depending upon the number of requests that has been represented here properly, that if the number of requests is increased, then the load balancer is also increased in this way. Now, the scope of this paper is to the knowledge discovery in database within storage, maintaining average performance, response time, and calculation and presentation of the dynamic load balance monitoring. Now, the summary of this paper is it mainly achieved the less response time. This is the by using this heterogeneous load balancer, it achieved the less response time consumption to direct the request in a particular service. In this way, it will get the effective technique and in the proposed framework. This load balance monitoring give the better time optimization, and by experimental result and graphically it has been proved that the response time, average response time, is less than the existing all other response time, and it will give the better and high performance result by using this proposed framework. And it has been proved that the according to time and according to better resource utilization, this type of framework give the better result than the other existing algorithm. Thank you.
Yeah, thank you, Saswati, for this wonderful presentation. I just had a couple of, queries about. So, what you've done, how is it different from how load balancing was done till now? In the sense, I could not see any underlying algorithm. It's like you are just understanding the load requirements of various servers and accordingly balancing it. So are there any hardware optimizations or any other routing algorithms which you have taken for routing the different routes to different servers?
Actually, it has been done by the programmatically, and here actually by this framework, actually here is the combination of two existing services, and here has been shown that in service 3 there are number of connection is 4, number of connection is 10, and response time is 4. So if we multiply 10 into 4, that is 40, and if the requests are coming from the user through the heterogeneous load balancer, 40, and calculate the 40 each for each request. So request 1, request 2, request 3 is going to in this way, then it will be 1200, right? So when it will be 1200, when the request 4 coming, then we compare it this service 3 with the service 2. If we calculate the service 2's total time, that is 1200. So it's no reason to wait for the service 3 for the request 4. So it will be redirect to the service 2, because the 1200 and 1200 is same. So the loading time is here same. Request 1, request 2, and request 3 is going properly in the service 3. But for request 4, it will be redirected here because the 1200 and that is also 1200. So it will take the same time. So no reason to wait request 4 up to enter the service 3. So in this way, the heterogeneous load balancer redirect the request 4 and request 5 in service 2, and in this way the total n number of requests are calculating how to, I mean, put the loaded the request in a particular service. That is the basic mathematical calculation in the total framework, and I did it by the programming.
But aren't there algorithms like shortest job first or concepts like that which could have been actually used to make the distribution of the services much more optimal rather than just taking time as a constraint for deciding how the load balancing would be done?
Can you tell me one more time the questions?
There are also techniques like shortest job first, or taking the time that. So over here, as it seems, you have just taken time as a constraint for scheduling these or for balancing the load. But is that the most optimal way? Have you done some kind of other comparisons also with the existing techniques, which have used some other metrics to do load balancing to kind of come to the conclusion that this is the best possible solution for these kind of applications?
Actually, when I researched this about this load balancer, I had seen that there are different types of load balancer that is shown in the related work, but this combination, I mean, both criteria has combined with each other. And actually, I was thinking that the both combination, if combined with each other and calculated in that way, it may be give the better result, because these combinations, I mean, response time calculation, connection, and all other related works are there, but I considered these two related works, and these two related works give the less time. And I thought that if these two related work, if we combined with each other and make the new framework in this way, then it will give the better result maybe. So that I calculate in that way, and I got that yes, this is give the better result. So I just want to try to do in this way, by using these two, I mean, framework.
Thank you.
That was my thinking. Yeah.
Sir, do you
Hello.
have any question?
Sir, it's not audible.
Oh, apologies. I think my question has been covered with the previous question. Mine is just a comment, basically, where I was concerned with two things of meaning the highest number of requests you've put through, just to check the scalability of it, especially when the demands are high. The second part, it was the comparisons. I think you need to do thorough comparisons so that you can check the limitations on how you can go about improving your proposed heterogeneous load balancing. Because of, if you can look, you can check, there are some of the different proposed frameworks for balancing. Therefore, now it's best to do the comparisons thoroughly so that you can show why yours is better than others, especially with the comparisons of results compared to others. Thank you.
Can you tell me your question? I mean, you just want to know what?
No,
Sorry.
it's a comment that's compared to a question where I
Okay.
said to do additional comparisons, especially looking at some of the balancing frameworks compared to the ones you developed. Uh, how is it, if what makes it to have an upper hand, and what are its limitation compared to others, so that you can work on perfecting it over and over time, because of all of these frameworks, they've got their own limitations. Therefore, it's essential to show which limitations your framework is addressing. Thank you.
Okay. And you are suggesting me to take another, I mean, framework and compared more comparison I have to represent, right?
Yes, for the future
Okay.
work.
Okay. Okay.
Okay,
Okay. I obviously remember this, and I am trying to do that for the better improvement of this paper.
okay, thank you. That's all from my side.
Okay.
Thank you so much, presenter, for your presentation. And moving ahead to our next presentation. To present his paper on enhancing educational methodology, generative AI within the project-based learning.
Thank you for the opportunity to present my research. Can I share my screen?
Yes, please.
Thank you. So can you see the
Yes, it's
presentation?
visible. Yes.
Okay, just in case, I will close my window or other windows. This presentation, this research is focused on the use of AI in education. We know that today young people, students constantly use different AI tools. So our responsibility as teachers, as educators, is to help them to use these tools wisely. Here is the brief presentation of the content of this talk. What is the motivation? Which are the courses where we apply this observed use of generative AI tools, what is our methodology, and I will discuss some initial results of application of this methodology. We live in a world where all organizations in all companies increasingly rely on data in order to run their business more efficiently. So the demand for data-educated people, for professionals, employees with a high level of data literacy is really at very high level. Speaking about different kind of computing specialist, information system professional, information system specialist, unlike computer scientists, software engineers, data engineers, and so on, have some different direction of their education and their role, because they need to prioritize the business impact, the business value of using technology in order to solve some problems and to help management to make informed business decision. So when working on different projects concerning development information system and the real use of these information systems, it is very important to be known the domain, to understand the specific of the domain, and in this case, working on project, obtaining practical skills in addition to the knowledge is very useful for students that are educated in information system area. So we apply our method for two courses, two different courses that are sequentially provided in two semester. These courses are information system analysis and design and project management. Both courses are mandatory in the undergraduate information system program at the Faculty of Mathematics and Informatics at Sofia University, Clement Ohridsky. During these courses, the students work separated in teams on the same project. The focus of the project is preparing a prototype of a small information system in a specific subject area. So different topics of software development are discussed: stakeholder identification, requirements elicitation, distribution of work over the time, risk management, quality management, database management, and many other topics are discussed. The point here is that we apply our method for during these two courses, because dividing the project task into two different courses and 2 semesters increase the time for the work on the project, and allows an iterative approach to project work in which students can constantly build their knowledge and practical skills. On this slide are mentioned the basic topic and tasks that are connected to this topic. You can see that information system analysis design is a classical course that is connected to the concept of information system development, system life cycle, and so on. The focus here is on the first phases, analysis and design, and student deal with stakeholder identification, the method with communication with the different stakeholders. They prepare use case model, OML diagrams, and prepare high-level design of the systems. The other course, the project management course, study different more organizational aspects of software development. Here, mainly the PMI methodology is presented, but also we discuss some agile methodologies like Scrum. Here, the project tasks concern again requirement specification, preparing the WBS, the structure of work packages, program schedule, cost estimation, risk management, quality management, and some other tasks. In both courses, students work as teams, but they have to prepare team projects, and also every student prepare his individual projects. These projects are supported a lot of documents, diagrams, notice, and also there are several presentations where students present the result of their work. So in our methodology, we focus on several main components. Of course, these are participants, students, and teams. We apply different ways of involvement of AI tools for these two courses. And because of the specific of the courses, we assess different components, different data are analyzed, and of course, some evaluations, some results were obtained from both courses. Here we can see a more detailed element of methodology. I mentioned we work individually with students, we work on team level. Not all tasks are involved in this experiment with using the help of some AI tools. Only two tasks from the first course, stakeholder identification and the methods for requirements identification are under evaluation, and project work breakdown structure from the second course is the task where student can use AI for their projects. In both courses, student first work alone, and after that they use the help of some AI tool. And we observe the documentation of the team projects, individual projects, and also all students that use some communication, some help of AI should present the works of this communication, and also to present a short resume of short discussion of where they discuss which of recommendations of the AI tool are used, why, and why not. So we choose these tasks for presenting the possibility to use AI because, for example, stakeholder identification is a very important task of software development. But understanding different stakeholder groups, their interests, their role, prioritizing them, it's not so easy for undergraduate students. So students are asked to work on this task first alone, and after that with the help of AI. For the second course, project management, preparing the structure of all work packages is also a difficult task for undergraduate students because usually they miss some of organizational aspects of the work.
Sorry to interrupt, dear presenter. You have last 2 minutes.
Oh, sorry. Okay. So there is one more specific in our work. Let's mention this specific. During the first course, in every team, students were separated into two groups. The first group was asked to use AI only for stakeholder identification and not to use AI for obtaining method for requirements gathering, and vice versa with the second part of each team. And during the second course, only one student of every team work on WBS, so only one student of each team use the help of AI. We had 6 teams. Each team consists of 8 to 9 students. They prepare all these documents, artifacts. They presented several times the result of their works, and I briefly will mention the results from these 2 courses. Although the students managed to prepare very good initial list of stakeholders, students did well in defining of so-called operational stakeholders. The stakeholders that work on daily or short-term activities with information systems. As about strategic stakeholders or general stakeholders, here AI was very helpful. As about the task concerning the second course, preparing WBS, again, the result shows that students work better or low level of all tasks, but they miss some activities that concern organizational aspects of projects. I should mention that according to opinion of all these students, they are not entirely satisfied of suggestions provided by AI tools. Here are some of their notice. But in conclusion, I can say that this incorporating of AI assistance into the work of the projects on information system development was successful and beneficial for students because it broadens the scope of all addressed issues and topics, but it could not replace the student work, and the student realize all this specific of using AI tools. So finally, we can conclude that AI can support students' outcomes when it is carefully assisted, when it is monitored very carefully, and when it is applied for specifically selected tasks. Thank you. Sorry for the time schedule overloading.
Yeah, thank you for your presentation. I just had one question. Like, with so many large language models available today, was the method tested on other large language models also, or was GPT the only model that you used for your pilot project?
Um, Almost all students used ChatGPT. Only one student used Gemini. All students use these tools. They ask questions in Bulgarian. So probably this is some kind of limitation of the possibility of the tools, but nevertheless, we see good, optimistic results.
Yeah, just a suggestion, it'll be good to even look at open source models like Llama, Lava, Quen, which are at par with what GPT produces, and then it gives you the flexibility of having models
Yes,
on-prem with
this is the thank you for this comment. This will be the next step. We also have Bulgarian ChatGPT, Bulgarian version of ChatGPT. So this will be the next step because this was our first experiment. Students were free uh, to use tools that are not recommended. They choose what tool to use.
Okay, afternoon. I think on my side, it's more of comments as compared to questions, especially is what I was about to highlight to you that when it goes to these AI tools, you gotta be careful because of at times they are not good at incorporating the environment where you're coming from. Especially for me, based in South Africa, what I've seen, you need to trade it over and over time, especially on how you put through your stuff so that it can reflect your context.
Yeah.
What I've learned with it is that it relies with so much data, but it is failing to take into consideration where one comes in, whereby my recommendation it will be, yes, I'm happy you developed one where we need the AIs which are based on different continents and countries, especially looking at the settings which are quite different. Then the other thing which I'll recommend needs to be done moving forward, instead of just focusing on the use of AI, also look at the element of using AI in an ethical manner because of it should be used in the process of learning so that the student can enhance their knowledge, their skills, even the competencies. Instead of generating the results, they should go about how can we use it for our benefit for our long term, so that even in future, if AI is not there, but we know we are competent enough because as universities, we are expected to produce the students who are competitive irrespective of the environment. Therefore, I think they should use AI not as a main tool, but as a complementary tool to
Yes,
enhance their
yes. This is the point. This is the point, and we use this help of AI only for more business aspects of the projects which are more difficult for undergraduate students. Probably for graduate master students, this help will not be needed, but we see that the business side for students at third year of their education is hard to be observed. This is just one more tool we can use it carefully, but it will not replace our way of thinking. And it is nice that students realize this. We can see from their projects for the discussion of the results. Any questions or comments? Thank you. Thank you for the comments.
Thank you so much, presenter, for your presentation. Now moving ahead to our next presentation. A paper presenter is Prashant Watts. I think he's not in the meeting. So moving ahead to our next presentation. To present is a paper on operationalizing CSRD compliance in IT firms, a thematic analysis of ESG and organizational practice. The paper presenter is Mikhail.
Yeah, good evening. Let me share my screen. 1 second. Let me share this.
Dear presenter, you may please start your presentation.
Yeah, I'm about to share the screen. Okay. And here. Yeah, good afternoon, everyone. Am I audible enough?
Yes, it's audible.
Oh, okay,
Yes, we
good.
can hear.
Okay, good. Good afternoon, everyone. My name is Mikhail Oladisa from Lutz University in Finland. We'll be presenting our paper titled Operationalizing Corporate Sustainability Reporting Directive Compliance in IT Firms, a thematic analysis of ESG and organizational practice. To start with, we ask this question: why does this work? Why does it matter? Corporate Sustainability Reporting Directive, which is CSRD, as we know, is a successor to NFRD, which is Non-Financial Reporting Directive from the European Union Commission. The CSRD applies to large organizations from financial year starting from 2024, and its mandates are three key things: double materiality, value chain transparency, and external assurance. So for IT firm, over the years, IT firm has been identified as both a contributor and an enabler of sustainability issues. On one hand, digital technologies is approximately contributed approximately 8 to 10% of EU energy consumption, and up to 2 to 4 greenhouse gas emission of energy share. So with this, we conclude that digital tools can as well improve traceability and as well as assurance. So in this case, IT firm must translate regulation into capability, not just report. And such report must follow the standard ESRS, which is European Sustainability Reporting standard. So for this question, we ask one major question: how are the Nordic IT firms responding to CSRD compliance? Looking at the requirement of CSRD and the EU, we define the scope of our topic of our work within the Nordic IT firms. And with that, we are through this paper, we contribute early empirical study as well as a process-based view of early compliance within the IT sectors. So our design study, this design study, we employed the case study whereby we selected 14 Nordic IT firms. The IT firms are anonymized in the study, and then we study what they reported in their publicly disclosed annual report. So we focus mainly on the sustainability reporting, what they discuss, and how the influence of CSRD directive impact the organizational directive. So for this, we analyze thematically, and we present our thematic outcome using the GEOA structures. For sample snapshot of our 14 firms, they cut across the Nordic countries, and at the same time, they cut across different sectors of IT, infrastructure and service, software development and IT service, telecoms, as well as IT services. So these are the overview of the company that was selected. And among these 14 companies, key things emerged, like in terms of how they prepared the CSRD report in in the 2024 report, why some of them are, just a few of them are completed it internally without any influence from external vendors. But others use external, they rely on external because of low capability, while some combine both internal and external vendors to prepare the report. Findings. Our findings were based on three response areas. One is organizational transformation, strategic alignment and drivers, and transparency and accountability. So as a result of the CSRD directive, organization redefine their board level ESG oversight. ESG here is environmental, social, and governance oversight. Most organizations now set up what they call disclosure committee and cross-functional governance, combining different different departmental level, as well as internal capacity building, training, academy, employee literacy, so as to improve the internal capability of the organization. In terms of strategic alignment, most of the firms that we review are now embedded sustainability KPI into their innovation workflow. And circular services and AI governance are now being linked to CSRD. As such, CSRD is now being used as a leveler for new value proposition and market positioning among the IT firms. In terms of transparency and accountability, most firms now integrate ESG reports within the financial, apportioning the same financial rigor to ESG reports as a result of the CSRD mandate. So as such, this requires them to expand assurance and restatement, especially on scope 3 coverage. So as a result of the demand of transparency linked to CSRD, there is now improved stakeholder expectation among the investors as well as civil society organizations demanding more sustainability concern from this organization. In terms of findings, after going through the 14 organizations, we try to conceptualize what they report, how they report it, and we now link them to a kind of maturity matrix. So we position those within high maturity are those firms that reported comprehensive scope 3 disclosure, as well as a strong ESRS alignment, that their report was actually aligned with the European sustainability reporting standard. So from our study, 5 was mapped to high maturity, 7 was mapped to intermediate, as Y2 was merged to emerging. But why this might not be standard across all the organizations, this was mainly based on what they disclose in the annual reporting. So meaning that the annual reports guide our mapping to the maturity here. In terms of our findings again, while they are doing this, most of the organizations reported implementation challenges. And most of the challenges were mainly interpretative, especially on double materiality, boundary setting, and how to define the categories. Why this has been in place, specifically for IT, there have not been a clear sector goal, sector define on what IT firms, IT organizations should report, how they should define it. And in terms of technical challenges, some of these organizations have silo systems, the existing ERP system, enterprise plan management system, and as well as fragmented data sources. So it's difficult for them to harmonize all these reports to cover scope 3. While all the firms they did well in reporting scope 1, scope 2, but for scope 3, it's been a big challenges. for IT industry. And related evidence from other sectors reveals similar things as well. So meaning that IT sectors are not alone in this interpretation of Scope 3 and data collection for these Scope 3 directives. So as a result of the directive demanded from CSRD, so there is more demand from stakeholders now on what organizations should report, what they should engage on, and as well as uh, cultural, hold on, as well as how they should be culturally responsive in the in their obligation, not just in their products and services, but as in their responsibility to all the stakeholders as well. So after our thematic analysis from the report, we conceptualize a CSRD-driven compliance framework specifically for the IT sectors. So in this, we identify four key things. Input, what necessitates this? First one is regulatory prayer, the sectorial maturity, which covers the IT as a sector, and individual firm maturity, as we presented uh, in the matrix earlier, like independent, because before this CSRD, some of the organizations that was covered, some of them have been even voluntarily reporting on sustainability. So we show that their commitment to sustainability has been established even before CSRD. But with the emergence of CSRD, it pushed them further to do more. And in this case, apart from the input, the key mediator is the governance structures and the preparation strategy, technical capacity within each individual organization, as well as their level of stakeholder engagement. And what they do, what comes after, then the CSRD now leads to a kind of internal organizational transformation. It comes with its own challenges, improved stakeholder engagement, strategic integration, and following this, the key outcomes is the compliance quality, so which varies among some of these organizations. All these are based on self-reported evidence from their report. So beyond the compliance, we now position CSRD within IT firm as a kind of mediated transformation of governance and sustainability practice. What is the implication of our study for policy and practice? For policy, we think we propose that there should be a need for clearer regulatory guidance, especially on double materiality and Scope 3, sector specific that will be targeting, okay, IT sector, this is what should be done. But at the moment, the details about each sectors have not been fully clarified. In terms of practice, there should be cross-functional ESG governance across individual organization, and auditable data pipeline and incentive per each department tied to ESG outcome. For example, pushing, okay, those in the product development that, okay, going forward, our product must be designed sustainably with sustainability in mind when we are developing. So we think each company can tie a kind of incentives to some across their departmental level so as to promote further ESG outcome. So this study signal a kind of shift in the role of IT as a sector from just being a compliance support to a strategic enabler of ESG integration. Because in other organizations beyond IT sector, most organizations rely on input from digital technology to actually meet up with their sustainability mandate. So while conducting this study, we acknowledge the limitations, and one of the key limitations is that the report was based on our limitation is based on public report bias, and the study is mainly focused on the Nordic IT firms, so which might not really represent the entire EU-wide as maturity. And at the same time, these companies that were selected were early stage. Majority of them were at the early stage of the CSRD reporting. So which means the report were only based on 2024 annual reporting. So subsequent one might provide more insight. In terms of our future work, why this was mainly based on document analysis, we propose that we want to,
Dear
we will
presenter,
follow up. Yep.
sorry to interrupt. You have last 1 minute.
Okay, good. We propose that we conduct interview with practitioners so as to link what they reported in their annual report to actual practice. So in conclusion, we concluded that yes, CSRD is actually catalyzing governance and data upgrade, and it's not just a reporting mandate. In terms of digital maturity, CSRD made it readiness and assurance among IT organizations, and compliance that improved system can actually indeed sustain value. So among our firms, high maturity firms are actually linked to better ESG to product and market strategy. And we concluded that regulatory prayer alone is insufficient to actually drive organization sustainability. So it will rather involve deeper change within individual organization as well. While compliance can foster continuous improvement, um, internal internalizing the compliance, it can guarantee long-term sustainability integration among organizations. So thank you. Any question?
Dear sir, any questions regarding the presentation?
No, I don't think so.
I think there's a no question. Thank you so much for your presentation. Now moving ahead to our last presentation. Quantum intelligence, funda foundational framework for a post-classical cognition. A paper presenter is Alan Jacob.
Yeah, hi,
Dear
am I
presenter?
audible?
Yes, you're audible. You may please start your presentation.
Yeah. Is my screen visible?
Yes, now it's visible.
What is quantum intelligence? When I talk about quantum intelligence, I don't mean running AI on quantum hardware. That's quantum machine learning, and that's a different field. Instead, what I am proposing is a framework of cognition that itself borrows from quantum principles. For example, in quantum mechanics, we have superposition, the idea that multiple states can exist at once. In cognition, this means that a system can hold multiple interpretations simultaneously without forcing a choice too early. Then there's entanglement, where one particle influences another. In my framework, meanings are entangled too. The interpretation of one idea shifts depending on the context of another. And finally, collapse, when observation forces a system to take a definite state. In cognition, context does the same thing. It resolves ambiguity into a coherent outcome. The goal here is to move beyond classical AI's pattern guessing and statistical guesswork and to increasingly model intelligence as interpretive reasoning, fluid, contextual, and dynamic. The cognitive superposition manifold. This is the heart of the framework, the cognitive superposition manifold. Think of it as a structured space where different interpretations, beliefs, hypotheses, and meanings can coexist in superposition. Instead of forcing the system to immediately decide between them, it lets contradictory states live together. Mathematically, I sometimes describe this manifold as an n-dimensional Mobius strip. A Mobius strip is a surface with only one side, And if you trace it, you never hit an edge. In the same way, cognitive states in this manifold are non-orientable and interconnected. You can't cleanly separate them. And just like cutting a Mobius strip gives you very different outcomes depending on where you cut it, collapse in this framework depends on context. Observation reshapes the manifold and forces a particular resolution. But that resolution is always tied to how the context slices it. So basically what this manifold does is it provides a way to model ambiguity, entanglement, and collapse as fundamental to cognition, not as errors, but as the actual structure of thought. Let me ground this in a scenario that I call the double agent dilemma. Imagine we are tracking an operative agent Z. Over time, we see signals that could mean three things. Z's loyalty to agency alpha, Z secretly working by agency beta, or just playing both sides for personal gain. Now, a classical AI system has no choice but to treat these as mutually exclusive categories. It assigns probabilities, maybe 40% alpha, 30% beta, and 30% independent. But the problem is those probabilities ignore the fact that the interpretations themselves aren't independent. For example, a message that looks loyal to alpha changes meaning entirely if we also suspect collusion with beta. Context reshapes interpretation. That's where quantum intelligence works differently. Instead of forcing a winner, it holds A, B, C together in superposition. The identities are entangled. Meaning shifts as context shifts. And resolution doesn't happen until the system has had enough contextual pressure to collapse into one coherent outcome. So, instead of premature clarity, we get a model that sustains ambiguity until the evidence truly warrants a decision. This second case study comes from clinical decision making, where the cost of premature resolution can be life-threatening. Imagine a patient comes in with ambiguous symptoms: fatigue, weakness, some inflammation. Three possible diagnoses emerge: Guillain-Barré syndrome, which is rare but urgent, psychosomatic fatigue, or post-viral fatigue. Now, a classical AI system will treat these as mutually exclusive categories. It assigns probabilities, say 20%, 30%, and 50%, and then recommends whichever is most likely. But the problem is that these probabilities ignore the way interpretations depend on each other. A symptom that looks harmless under one diagnosis can be critical under another. In this example, the system converges too early on post-viral fatigue, and the patient's condition deteriorates because the true condition was Guillain-Barré. Under quantum intelligence, the system doesn't force a single winner too soon. It sustains all three diagnoses in superposition and lets context reshape the interpretations dynamically, and only collapses it into one diagnosis when the evidence actually demands it. In other words, it delays commitment, not out of indecision, but to preserve accuracy under uncertainty. Temporal dynamics in the CSM. In classical systems, time is treated as something external, like a clock ticking in the background. In quantum intelligence, time isn't a background. It actually emerges from collapse events. When a superposed state revolves, it's what we experience as the present moment. Everything that has already collapsed becomes the past. Everything still in superposition is the future. And because collapse is irreversible, you can't uncollapse a decision. That gives us the arrow of time. So basically, this explains time in a way that normal physical systems cannot. Like for example, if we look at thermodynamic time, it is defined as the direction of time is defined as the direction in which entropy increases. But as we begin to dig deeper into it, we do not get much more of a convincing explanation than, for example, since entropy is disorder, the number of disordered states in a system are much more likely to occur than ordered states. which is more of a statistical explanation than a true reason as to why time exists the way it does. Here we can easily explain the arrow of time through the cognitive superposition manifold. So here time isn't just measured, it's created by the act of resolving uncertainty. What is entropy in the cognitive superposition manifold? In classical physics, entropy is usually described as disorder, a system naturally spreading out into more possible states. In quantum intelligence, I reinterpret entropy as interpretive tension. Each resolved state in the manifold carries ambiguity. When a collapse happens, that local ambiguity is reduced. So entropy goes down in that region. But at the same time, the collapse reshapes the manifold, creating new entanglements and fresh tensions elsewhere. So, instead of entropy as disorder, here it becomes the cost of coherence. Every act of meaning making resolves one ambiguity, but in that presence, it generates pressure in the rest of the system. Early evidence and next steps. So, where are we now? At this stage, quantum intelligence is still a conceptual framework. There's no running code, no benchmark dataset, no hardware implementation yet. What we do have are some early stress tests. For example, when I put generative language models under recursive tension, asking them to sustain contradictory states, they didn't just hallucinate randomly. They broke down in ways that mirrored exactly what the cognitive superposition manifold predicts. Premature collapse, local coherence, but global distortion. That gives us a first hint at what the model is capturing something real. The next steps are clear. Developing a formal algebra for the manifold, building simulation models, and exploring hybrid quantum classical architectures to actually host these dynamics. So this isn't a finished system per se, it's the foundation of one. Our goal now is to invite collaboration, formalization, and challenge. To conclude, quantum intelligence isn't about running classical architecture on quantum hardware. It's about rethinking intelligence itself as quantum in structure, ambiguous, entangled, and context sensitive. The cognitive superposition manifold gives us a way to model that, where contradictions can coexist, meanings reshape each other, and collapse only happens when context demands it. The case studies show how this approach can handle situations where classical systems fail, ambiguity in strategy, or life and death ambiguity in clinical diagnosis. And the theory of time and entropy reframe cognition itself as an ongoing cycle of collapse and renewal. This is still early work, but if intelligence really is quantum in nature, then the path forward is not just bigger datasets or faster GPUs. It's a new paradigm. That's what I'm inviting you to explore. I would like to conclude with this line. We taught machines to think in lines. Quantum intelligence will teach them to think in clouds. Thank you. Does anyone have any questions?
Thank you so much, presenter, for the presentation. I would like to ask, sir, do you have any questions regarding the presentation? I think he has no question. Thank you so much, Alan. And now we have concluded the session. I sincerely thank our author for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 9th version and the previous 8th version of the conference. We will be happy to have you in the next 10th version in 2026. All the presenter would be getting digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of WS4. I also thank our session chair for chairing this session. Thank you so much, sir, for your valuable presence.
Thanks.
And I would like to request to switch on the camera for a quick snapshot for a virtual conference. Thank you so much, everyone. Thank you so much, sir. Thank you so much, ma'am.